Welcome to Tomorrow Makers, where we explore how we learn, live, work, and play now and in the future. I'm Carlos Ramos.
And I'm Summer Beatty.
Hi, Summer.
Hello.
How are you?
I'm great. How are you?
I'm wonderful.
It's always a good day when we have a great podcast recording.
It is, and this one was really good.
I love the topic of neuroscience. I'm a big fan, and now after meeting our guest, an even bigger fan.
Yeah, I could see you over there kind of geeking out as I'm slowly fading. I'm like, oh, there's so many chemicals going on.
And I'm like, tell me more about potassium, please.
So who do we have?
Yes, so we have Dr. Justin Ingram, and he is an instructor here at Penn College, a neuroscientist. He also gets involved with brewing. He talks a little bit about his band. I think we covered more topics in this one than possibly any before him.
It was just so fun. We're just watching two you go back and forth. And I finally was like, I have to have something to say. So
I can't help asking questions. I don't know that we covered everything on the list, but probably a lot of really fascinating topics. We think you're really going to enjoy this one.
Yeah, so definitely take this one, listen to it twice, share it, get the word out on this one. This is Tomorrow Makers.
Enjoy.
Welcome, Justin, to Tomorrow Makers. Why don't you tell the audience a little about yourself?
My name is Justin Ingram. I have a PhD in neuroscience. I have degrees in biology, chemistry, nanotechnology, and then I went to grad school to do neuroscience. And I've been involved in research for a good chunk of my life. And I've been here at the college for just about 10 years. So I do a little bit of research. I do a little bit of teaching. I did a little bit of promotion. And now a little bit of podcast.
Yeah, before we sat down here, what were you saying? You were cutting up.
Yeah, so I taught anatomy.
And
I teach anatomy and physiology here. So we were doing some sensitive areas today was the topic of reproduction. And now we're doing beer and science podcasts. So it's been an exciting day.
How did you end up in science? Have you always been interested in that career field? Or?
Yeah, I've always gravitated towards puzzles and solving puzzles. So the idea of solving a puzzle then transitioned to the human body, and how could you take the human body and learn something from what other people have done, and then maybe learn something new that nobody's ever seen or nobody ever experienced before. So I got into cancer research early on in my early research days, and was able to put together some projects that nobody had an idea of how to do or even know where to start. So when you get the right people together at the right time with the right experience, you can make sometimes big ideas happen. So once I was able to get into some of those professional settings, I learned a little bit. I then started to experiment a little bit, and now it's led to a career in science, which I get to teach and promote and change the lives and maybe change the research minds of some of the kids that come through our classes as well.
So why science? What excites you about the area of science?
So as a kid, I always thought that people knew everything about the world. Or at least I thought at the time, this is little Justin talking. I was always under the impression that people knew diseases and disorders. So then your family gets those diseases, right? You look at what other people do, and you see that there are some holes and there are some gaps, not only from a technology standpoint, as you look at now compared to what people knew 5, 10, 20 years ago, but as people slowly start to learn bits and pieces of whatever disease you're thinking of, people can then piggyback off of that and then learn a little bit more or apply something from another discipline or from another disease to now a new specific disease that you want. And then the scientific field grows. And I thought that people knew those things. I thought that many of the diseases that you've heard of, and you close your eyes and pick one, that's the one we're thinking of, that people knew a lot about it, about what it was. And I slowly learned throughout my college career that was not the case. And there are holes and there are gaps. And if you want to solve those gaps, you got to get the right people at the right place and at the right time and know enough about the system to make some educated, experiential guesses to figure out what you could do next. And that was something like solving puzzles was a really neat piece. If you could get in there at the right time and add something new, even though what you're doing might not be as super relevant to that topic, it could be picked up by somebody else and they completely revolutionize a new field, a new technology, and learn something new about something different. So that's why I've always been at least gravitating towards science. It's just a big continuing snowball that gets bigger and bigger and bigger as people learn more throughout their years.
Yeah, you had mentioned earlier about cancer research. What did that look like?
Yeah, so I went to school at Lock Haven University. I got a degree in biology and chemistry and nanotechnology. And the first job offer that I had was building these small sensors that I could put in brain tissue. And that was the idea. Like, how do you engineer a very small nanoparticle version of a sensor or a delivery system to thus try and target a cell or see a cell? And again, it was a background of a combination that I was working at the Department of Neuroscience and neurosurgery at the time at Hershey Medical Center. And we were able to answer those questions and build a delivery system. So then you not only become somebody who knows a little bit about science, but you're able to create something brand new that other people can piggyback off of. And that's where I really was like, this is what I want to do. This is the career path I want to go after.
Yeah. Is that technology being used today?
In different forms, yeah. So it's transitioned into, can you get something from the blood to the brain? And can you target a cancer cell and potentially shrink it? And then after that, it turned into, well, if you can do that, what else can you do? Can you do sensing? So then my graduate work didn't focus on cancer delivery, but how can you sense small domains around cells and learn what those cells are doing now, and then hopefully understand what they're going to do a minute from now or 15 minutes from now. So it became a predictive measurement where I was related to like solving the weather, right? If you want to know the weather, you got to figure out the barometric pressure, you got to figure out the times, the temperatures, you got to understand dynamics of fronts coming through. And in the realm of biology, if you can figure out sodium, potassium, calcium chloride, if you can understand micro domains around cells, you might be able to predict what those cells are going to do in the future. But to do that requires a sensing technology and a delivery system to make that happen. So yeah, it's been used in different fashions and different forms, but at the end of the day, it's delivery, sensing, cancer research, predicting what cells are going to do, all based on technologies that we were able to accomplish.
In the area of neuroscience, it seems like you clearly have a passion for it. Are you still involved in research in that area?
Yeah, so after I graduated from Penn State, the projects were carried on by some other folks. And then as they graduated, the projects slowly started to die out. And then COVID happened. And when COVID hit, the pandemic sent us all home, and I was sitting at home for quite a while. And that brought some reconnections to some other folks that I haven't talked to in a long time. And we said, hey, what if we did this? What if we did that? We now had time, and all of us had time. So we were bored, and we decided to put our boredom to good use and start looking at different projects, which are now going out right now, which is kind of exciting.
Anything you want to talk about? Or is it still
still
early?
It's sensing. It's sensing using different technologies of fluorescence to try and understand, again, in real systems in real time, what's the weather like today in the brain and what's the weather going to be like tomorrow. And the lab that I happen to work with is in hyperexcitability. So they do seizures and they do epilepsy. So in the realm of epilepsy, you want to be able to understand if I'm going to have a seizure in 5 minutes or 10 minutes, and not just necessarily an aura, but could I predict when that was going to happen? And we have some preliminary evidence to suggest that there could be some metrics you could look at.
Oh, interesting. So are these sensors in somebody's brain all the time?
Not yet, yeah.
No.
That's the idea. So
Okay.
so doing that realistically in human beings becomes the other challenge, and the lifetime of that becomes the challenge. So that's some of the stuff we've been working on over COVID of could you do this in systems that are real life, acting, moving, and these can't be wearable like some of the watches and some of the things that people have. They have to be implanted inside to get deeper into tissue to understand what that tissue is going to do. So that takes time, and it takes energy, and it takes a lot of money. And that's at least the direction we're thinking right now.
Do you have I was just kind of thinking with the epilepsy connection, do you have a specific passion for that area, or is it just sort of where your research landed?
It's at the time where the opportunities landed, and it's a gigantic event in the brain. So it's an easy thing to measure for sure, but it's a big event that you could make predictions off of something really big instead of a smaller blip of time. The seizures can be very long lasting, they can be chronic, and they always burn themselves out. At least most of the time they burn themselves out very quickly. So they were easier things to measure with the types of sensing we were doing. So no personal connection, but at least a personal interest in being able to sense something big that was relatable to a human population.
As a researcher, if I were to say, I have $1 million to give you to do some form of research, what would you do with that?
I've been after the holy grail for a while. My thing is potassium sensing. That's been the one thing I've been trying to do. And so your brain runs off of different chemistries, right? And they move in and out of cells and they send signals. So the $1 million, and it would probably take more than $1 million, but
I'm naive. That's a lot of money to me. So
the idea would be, how many different metrics could I measure in your brain in real time right now? Not estimate them, not use calculations necessarily, but in real time, real metrics. Could you measure specific elements in real time? I can do oxygen, but some other ones would be really nice to figure out. Potassium and sodium would be really big in real time, and I would go after potassium next. I've been trying to think of creative ways to do that for the past 10 years, and I don't have the time right now. I think I have the energy. I definitely don't have the money. But if I had an unlimited budget, I would go after real-time sensing. Then you truly understand what your brain is doing at this moment in time and then predict what it could do in the future. And this is true for disease. This is true for aging. This is true for just normal pathology of any disease. This is true for just normal functioning of the brain. How much do I know about your system right now? And the more you understand that, the more you understand not only the system, but how it can age and progress and cause diseases.
Why potassium?
The oxygen work we were doing, we were finding blips of hypoxia before seizure events in tissue. So the reason of that is something we've never been able to understand. And there's a few ideas that some of us have come up with, but it requires, okay, so if oxygen drops before a seizure, why does the oxygen drop? And there's some hypotheses you can make, but you need more sensing. You need to be able to backtrack. But if you did that, then you can maybe track a seizure even further in a blip of time. Not just in seconds, maybe minutes, maybe hours, maybe days, nobody knows. But there's something dropping oxygen before seizures, and we've been trying to search for that for some time now. I have a suspicion it could be potassium related, but you have to be able to sense potassium in real time, not just with math, but doing it with actual quantifiable measurements. And that's easier said than done.
So is somebody going to hear this and do something with it? Sorry, this is the topic you hear later and you say, don't mention anything about my secret potassium.
No, I'm not the only one, I'm sure, that's going after that holy grail. But any small piece that anybody could contribute, people are looking at how neurons are connected in your brain, right? Or pick another area of your body that could work too. But finding out as much information as you can about the system to then learn from the system and learn how to live forever, how to, keep cells happy, healthy all the time, how diseases truly progress, and then potentially treat the diseases, not just the side effects or just put a Band-Aid on things later on, but truly understand what put something there in the first place. And that's a very powerful avenue of science.
Yeah, and all this research just piggybacks on each other, like you said before. So
those sensors they could be used in other systems too, not just the brain.
Now, that work that you're thinking of, would it just be for the treatment of diseases, or are you looking at prevention in the first place?
Yes, modes of action is what I always say. Yeah, so understanding dynamics right now and then figuring out what puts something there in the first place. So I always use cancer as an example. Instead of cutting cancer out necessarily, what put the cancer there in the first place, which is easier said than done for sure. But trying to understand as much as you can about what caused the specific disease. And there's a lot of unknowns in the diseases that people know of today. And people do a lot of treatments of symptoms. They do a lot of mitigation to try and slow down the symptoms. But once you understand what put the disease there in the first place, then you truly get to the cause of the disease and you can eradicate it from potentially the entire population. Yeah, the holy grail.
I think if somebody reads your bio, they may on the surface see that you have this deep interest in science and research. And then the other side is brewing. So while on the surface, it may seem like they're two totally different, areas. How did you transition into brewing, or has brewing always been a part of your interests?
Well, that's a good question. So I started out with grapes, and I would cultivate grapes. I would do different versions that you could buy at local places and cultivate grapes and grow grapes and enjoy the juices, not just in the realm of wine, but grape juices for my kids are always great. And then we got into like French hybrid grapes. So now you're making some different versions of wine that not so many people had. And then I got hired at Penn College and I started to run the science department. I was the department head of natural science for 6 years. And they said, do you want to create a program, or can you create a program, or do you want to create something new? And I was like, yeah, we can do this, we could do that. We could potentially do this idea and this idea. And a lot of the ideas kept coming back to brewing. And at the time, I've been brewing for probably like 5, 6, maybe 7 years at my home, and I could make all these different styles of beer, and they tasted great, and they were cheap, and they were easily. It's all science, It's all yeast fermentation. It's all yeast researching, and they allowed me to create a program here. So we went out to industry, and then industry has been fantastic in the realm of beer. And they gave us opportunities. They gave us ideas about how to build a program, and then we got to build the Brewing and Fermentation Science Research Project. And I was one of the contributors to that. I got to see it as an idea, and then transition into a 2-year program, and then a certificate program. And then after that, COVID hit, and we were sitting around. We're like, well, what else could we do? Well, let's start getting into research. So I've been doing brain research for a while. We have some fancy pieces of equipment. They can measure fluids. Beer is a fluid. The craft beer industry at the time and still today is still growing and developing. And there's all these breweries nearby. So let's start looking into research. So I reached out to a good buddy of mine, and we were able to get a research lab in his facility. We have made friends with everybody in the industry, which is great. And we give them what they want. They want skilled labor workers. So I honestly don't know how it happened, but it was a slow accumulation of Penn College fit the bill for this flavor of program. It hits business, hospitality, marketing, graphic design, electronics, mechatronics, welding, science, and we had all those tools here. We just had to build the program. So once we went into industry and said, "What do you want?" They gave us a laundry list, and I started creating it and making it look like college classes, and that's the brewing program we have now, which is spawned off so many different brewers, which is so exciting. And they're in bigger name industries now, which is very exciting. And we're also doing research at several places very close to where we're at right here at the college, able to do something brand new in their realm. So brain beer, fluids are fluids, oil in your car, fluids are fluids, but we have some very similar technologies to sense oxygen, potassium, sodium, and those are much easier to do in beer samples or spirit samples or wine samples than, of course, it is in the human brain in real time. But still, it's kind of scratched that itch of doing research here that I just couldn't do really almost anywhere else.
Yeah. So I think if you think back to your choice to pursue, the sciences, and your other classmates may have taken different paths, and it's really fun that you came to Penn College, and I bet they're not getting an opportunity to study beer.
It helps everybody. It helps the industry because the industry wants to learn from their products. They want to make longer shelf life products. They want to make new products. They want to learn different techniques to make their products consistent. And that all comes down to using some fancy equipment, running some data, asking the right questions, and getting the right answer. So it's a much easier fluid to work. It's very complex for sure, but it's a much easier fluid to work with than, of course, brain. But there's a gold mine of information that we're trying to work with. And it's not just me. I'm working with other national labs now, which is extremely exciting. And we're trying to answer some questions in beer fluid dynamics that could be beneficial to specifically Pennsylvania, but really any craft brewery that's around.
So you have active projects, multiple active projects.
I have more projects than I can do right now. We have, I'm trying to get students involved, which is a pitch I'm trying to make and slowly getting traction on to try and get a small army of students to do different research projects. So 2 years from now, where we are is going to change completely. And I'm a one-man show myself with another professor that I work with here at the college, but we're trying to get an army of students because then you can really make some bigger name projects happen. And every student gets a different beer, and they track beer, and they understand beer dynamics, and then try and make more consistent, longer shelf life versions of products that people can potentially enjoy and savor.
Are there opportunities for research in the sciences, traditional sciences, I would say? As well
here at the college, not as much. So the teaching aspect of the college and what we do, we're slowly, and when I say we, I mean there's a handful of people. We're trying to do more research, especially when we're starting to get into programs that relate to grad schools and medical schools, where students could really benefit from some educational research component, whether it's something small or something big, but not just data mining where you're just collecting data from somebody else, but physically collecting data, understanding data, analyzing data, coming up with a problem, and then solving it the whole way through is something that we've been trying to work on here and slowly have been getting traction to do. So in biomedical sciences or from neuroscience, no. But for science in the realm of understanding something brand new, that's something that we're starting to do here more so than we have in the previous 10 years.
Yeah, I think at Penn College, it's like, if there's a will, there's a way. I think if somebody has the energy and the motivation to do it, there's usually backing.
Sure. And it just happens to be in beer, which is fun. The culture is fun. And I'm not saying like, let's go out and have a bunch of beers fun. I'm saying from a stylistic, artistic, creative, scientific standpoint and history of beer standpoint, it's really kind of neat to see how beer has changed and evolved and then taken up as an industry locally and then nationally, and how people get so creative with the products that they make. It's always been fascinating to me. And it's fun to help them not only standardize some of their processes and make better, more consistent products, but also make new products, which people really tend to enjoy for sure.
And so you created a lab outside of the college at a local brewery, right?
Yes.
How did that come about?
We found out that somebody was going to buy the old Woolrich Distribution Center, which is 153,000 square foot facility. It's been sitting vacant for years. My dad used to work there, which is kind of crazy. And the owner came to us, and I've known of the owner for a long time, and our families have been intertwined since we were little kids. And then I found out he was buying it, and then the idea was, how can we work together? So you have the Disney World of breweries. Like, you have this unbelievable space that you can do things that us at the college could never do, or even small breweries around here, that distillation techniques. I mean, big tanks. There's a lot that you have access to. How can we make that beneficial for students, number one? How can we make it beneficial for the program? How can we make it beneficial for the college? And then also from the faculty standpoint, like, what new things could we do? What could we experiment with? If you gave me keys to your brewery, what could we do? And then that led to me physically getting a space. So I have space in the back of their brewery, and we have access to other breweries too, which is very exciting. But it was a way to bring a professional scientist or scientists inside of a facility and then brew on the system or see the day-to-day activities and say, well, what if we did this? What if we did that? What if we measured this here or looked at this here? Would this increase your efficiency? And we have the tools to measure it. So it was kind of neat. It's a neat blend between like the science research background and then production brewing, and then seeing that blend and merge together as one entity where we all have the same goal. We're all trying to create something new. We're all trying to get the best products possible. Like, we're all trying to understand the products that we're working with. And for the students here, they're looking for jobs in those fields as well. So this helps absolutely everybody. So we have a chunk of real estate at a local brewery very close to us. And it's such a neat opportunity that you have access to information and technology and equipment that you would never have access otherwise. And it really gets like, and college is hands-on, and they're here to make industry partners. Like, that's exactly what this is. And it certainly can help the programs that we have here. And it scratches a research itch I've been trying to do for a while.
So when you conduct research there, what happens with it? Is it something that, I don't know how that industry works. Do you publish it? Is it shared among other breweries, or does it just stay?
It depends on the project. So what the idea of like a very generic overview is, we're trying to make fingerprints of beer. So if I know a fingerprint of any given beer, I can see how that fingerprint changes over time. It's kind of the same thing with the brain. You understand the brain's fingerprint now. How does the fingerprint change over time? And to do that requires measuring tools to measure as much as you can. So we have different projects running with different beers that you could really only do if you were at that facility. If I didn't, I'd have to go to a store and buy a product, and then I bring it back to the college, where now I can measure that product from its birth, like literally after it's done fermented, or even while it's fermenting. I can store it warm, I can store it cold, I can manipulate it any which way. I can have it distributed to anywhere and then potentially buy it back and then see how it's changed. So the idea of getting as much information on the brain or beer, like, it's kind of the same concept. Just when you're in a local facility like that, you can have access to the products, which is not only beneficial for them, but when little things come up that are innovative, you can publish that. And we have not published anything just yet, but there are some projects in the works that have some very significant applications to small craft brewing that would be really exciting to publish and showcase to other players, to not only show that Penn College has some pretty savvy people that know what they're doing for sure, but they can answer the right questions and they can put people in the right situations to do well in their industry.
Has there been anything you've discovered that has been applied in the facility where you're working? Like to the beer that's eventually getting right there to the consumer?
There has been some really innovative people that work at that brewery that have been able to solve some really innovative projects that have been, in my opinion, very revolutionary to the way craft beer is perceived and packaged and delivered. So the details of that will eventually emerge. But the idea is when you can get some really creative people to do some really creative things when they have time, you can change the course of some different industries, and brewing is no different.
I'm just curious, as in terms of motivation, do you have any mentors or anybody who's impacted you along the way?
I definitely have college professors that I had as a kid that definitely shaped my career path. I've had coaches as a kid that definitely changed my career path and kind of guided me towards one location and then the other. And that was all for science. And then the beer, I don't know. I've just been overwhelmed by the creativity of the industry, especially in Pennsylvania, and how passionate people are about their products and really how creative people can get. And I've always been fascinated with history and stylistic natures of beer. So yeah, there's been several handfuls, and we have to meet some of those heroes too, which is exciting, especially in the realm of science and the realm of beer.
So no specific mentor that you want to call out, just a lot of different supportive.
It's not just one singular person. Yeah, there's been so many small steps that shape you and pull you in different directions, and then that leads and snowballs to another direction. So everybody I've interacted with has helped to some extent, and I know that's extremely vague.
Oh no, it's okay.
There's been handfuls of people that have really shaped, and then that's been able to shape other people and students and careers and programs in the college. So it's a combination of a lot of people.
Yeah. I think one big takeaway is just that ability to work with really great people who are willing to just entertain those what if questions.
Yeah,
and
that's a big part of science. And when you have that, projects get done. When you have somebody that's really great, it's kind of like songwriting. You can meet some really great people that are musicians, but maybe not as good as a songwriter, right? And when you can get some really creative musicians that are also really good songwriters, then you start saying, what if we did this? What if we did that? What have you observed? I don't work in this every single second of my life. What have you seen? Why is this high? Why is this low? Like those little questions can spark some pretty big ideas that might not just be relevant to that question at that moment in time. And that's true for the scientific method as a whole, but getting people together that are super passionate and super creative is a big, big, big deal. And I've been lucky enough to be surrounded with a lot of those people in my life, which is fun. It makes it easy. It makes it a lot easier.
So you're a musician?
Yeah, pre-kids.
So I don't know if you told us your band's name.
The band is called Zero Hero.
Okay.
And we have not played a live show since my daughter has been born. Maybe we played one. So once we had kids, that was a lot more problematic. But that's the same thing. It's creativity, right? You get to be creative. You get to express yourself. You get to have fun. And if other people have fun with you, then it's that much better.
And there's some original music out there.
There's all original music. Yeah, there's 2 albums. There's a third that if I ever had time or energy, I would go. And maybe when the kids grow up, you never know. I don't know. We'll see.
Any musicians in the family?
No. Kids will sometimes play, but nothing. They're getting there. Like they're slowly understanding theory of music and being able to put songs together and then writing some lyrics over top of those songs. But yeah.
Oh, that's musical.
Yeah, that's we're getting
They're
there.
just studying the theory. Yeah. They're not. Well, you're not letting them do the play music yet.
My daughter is taking guitar for the first time.
Okay.
So when you hear it from dad, it's not the same as if you take it in a class at a school where the people are much cooler, I guess, than you are. Although my guitars are so much nicer, but like she's learning more and like being more open-minded to different music styles, more so now than ever.
What's her favorite band?
I don't know. It's probably some hip hop band. If I had to guess, it wouldn't be guitar so much, but she's a big Eric Clapton fan. But it's like Eric Clapton and hip hop, which she's all over the place. So
yeah, very different. How old is she?
She's 13.
Okay.
Yeah. My son's 10.
I'm seeing a mashup in the making here.
I know. I'm trying to get the Brady Bunch, get it moving, trying to get it worked out.
Do you have instruments set up at your house so they're accessible?
We have about every instrument. Yeah, you can imagine. Yeah, drums to djembes, guitars, pianos, cajones, every small egg shakers that you have. We have digital stuff, which is cool and sort of innovative. So yeah, half stacks of amps, small amps, big amps, everything. Yeah, we could put on a show if we wanted to.
It's just all there, the right musicians waiting to come to life.
It's vibrating and it's ready to be released whenever the right people can. We have people over and they play, and some musicians come over and we play, but not as much as I would like.
Yeah, on the surface, it does seem like you've got this brewing and you've got this science and this music, but to hear you talk, it all comes together. There's so many common themes.
Yeah, no, it's do what you love, right? Do as many things as you can. You want to get good at something, get good at something, right? You want to be great at music, get great at music, right? Put yourself out there, make mistakes, have fun with it.
So I'm imagining the home brewer that might be listening to this. And can you talk a little bit about how going through a college level program for brewing, because I don't imagine that a lot of people that are working in breweries have gone through a program specifically for brewing. They probably got into the brewery somehow and, just kind of observed and worked their way up. But that takes a lot of time.
It's a lot of liability on the person that's taking you in to make sure you are keeping on task, teaching you, guiding you, showing you mistakes that you may be making. So it's definitely changed. And I mean, we've been a part of that change, which is very exciting. We've been able to make sure people get into the industry that are not liabilities for any brewery that they're going to take. And the track record that we have speaks for itself. So when the program was being created, the breweries themselves said, we want students that can do English. We want math. We want students to be able to do these techniques, which then morphed into an operations of brewing class 1 and then operations of brewing class 2. Or we want students to understand more about ingredients well before they even see us, which led to an ingredients class. And then that led to packaging and distribution and brewery mechanics. So the evolution of a college degree has been there for some time now. And we came into it, I'm not going to say late in the game. We were still early in the game whenever people were learning that education was important in the realm of a trade, which it's been for a long time for a lot of different industries as well. But the idea of it was making educated scientific brewers, and that's exactly what we've been able to do. And you can talk to the breweries that have hired some of our students, and they will say that the students coming in are not just green, although they could be new. They've only been doing this for a year or potentially more, but they're not a liability as much as I just bring somebody in. That education has now shaped them and allow them to get their foot in the door, number one, but then also kind of thrive in their field and then be adaptable in their field. And they're going to be safe, they're going to be smart, and they're going to be able to make some observations as they're going on their day-to-day tasks, which is a relatively new concept for a trade like brewing. And other parts of the world, they don't have necessarily education. It's all apprenticeships. And you work with an apprentice, and then that could be years and years and years and time and energy. And if somebody doesn't pan out, you just lost years and years and energy dedicated to that system. So we were trying to make sure that whenever anybody came out, this was the standard that they had, and we could create a educated, literate workforce that had a skill set that was beneficial for what the industry needs now. And then as we work with industry partners, what it's going to look like tomorrow as things change and evolve.
So I'm hearing, while there might be an investment for the student, the ROI is almost immediate.
Yeah. So anybody that's thinking about it, talk to breweries. Talk to breweries that have hired our folks, and you don't have to go very far, especially in Pennsylvania. It's been really exciting to see where our students have been able to go just in the realm of brewing and create some beers that I see on shelves whenever I'm in a store or when I'm in the brewery, and they're like, hey, look what I've done. Look what I've been able to do. And it all came from an idea that happened, 2015, 2016. And now you see it come full circle where people like at the brewery I'm at now, like I see some of the graduates. At other breweries I visit, I see some of those graduates. You go to Straub and you see some of our graduates. Like, it's kind of neat to see how it's changed the landscape and brought brewing together and more educated, and even maybe brought some people into Williamsport that wouldn't have been brewers here in the first place. So it's really neat. It's neat. It's like, for me personally, it's neat to see the idea turn into, hey, I'm starting my own brewery in your hometown of Lock Haven. I was like, no way. There has not been since Lockport. Like, I can't remember of a hometown brewery, and now 2 people out of our program. Yeah, like it's yeah, and I'm like, this is such a neat. That was the idea. I didn't think it would be quite that big, but like it was certainly neat to hear that breweries come into towns, and then the towns do well, and then towns bring more people and more tourism and more restaurants, and sometimes the towns kind of evolve after a brewery comes in. So it's been very exciting to be through that process from the beginning to the end. And the students I have them to thank for it, because they've showed that it works. The system works, and we didn't build it from an accrediting body, or we didn't create it based on any one idea. It was literally from the ground up, which is very different than some of the other programs we have here, where you just say, what do you want? What do you need? How can we create that? How can we blend resources we have together to get somebody a job? And that's the educational advantage that you would not have otherwise.
And earlier you had rattled off a half a dozen different program areas that we have here at Penn College that kind of helped make this possible. A couple of them, seemed obvious. Having the science classes here that were already supporting our health sciences, but business and marketing, obviously for being able to sell that product. But then you mentioned things like mechatronics and welding. Can you talk about that a little bit?
Sure. So when breweries jump to different levels, they need different levels of equipment to brew at different scales, right? So now it's not so much of technique. It's about how do I heat a vat that's 360 barrels, right? A barrel's 31 US gallons. How do I heat and figure out energy from this point to this point? How do I move these liquids? How do I get these grains from point A to point B? If I'm going to package this in a packaging line, how am I going to do 256,000 cans a week? How do I do that? That's all machinery. That's all electronics. That's all welding. These tanks are gigantic vessels that can sometimes need welded, or they have to be custom built and custom fixed. So the brewing industry is not just about the brewer or the one singular person. It's a machine. It's a literal vibrating, living, breathing machine that's business, hospitality, all the things you're rambling off. Some people want to start their own place. And if you want to do that, you should know a little bit about how to brew, number one, but also a little bit about business, a little bit about maybe hospitality if you want to run your own pub that produces food. Graphic design is a big one too, right? So if we have 2-year programs in graphic design that you can blend, we have welding, we have mechatronics, we have business, we have those classes here to customize what you want to do with that specific lineage of brewing, right? Some people just see a really cool label in beer and they're like, hey, I want to try that. No idea maybe have an idea of what style it is, but the idea of it was what drew me to that product, which is some really crafty graphic design. So if you're cranking out beers, you got to be able to do that to some extent. And if you don't, you hire somebody at a pretty penny that's going to do that for you. So it's such an interdisciplinary, synergistic program and degree in industry. It's unlike anything I've experienced in the realm of business before.
It's the ultimate band.
It's the ultimate band where the right players have to be completely in sync to make some really stellar products. And there are some really stellar products that people are making.
You just brought everything together.
There you go.
Yeah.
So Justin, is there anything that you would really like the audience to take away? There's been so much so far, but is there one thing you'd really like to boil it down to?
Yeah, sure. Be curious, be open-minded. Look what other people have done. If you have an idea, you want to get into something, look at what other people have done and learn from that and take chances, right? Don't be afraid to fail. And regardless of what that is and whatever music or neuroscience or beer or whatever it is, give it a shot and see what happens. You might lead something new. You might learn something that nobody else has learned before, and that can lead to some really, really crazy advancements. And that's when, I always say, science gets really fun. Learning information is fun, but when you can start to manipulate that and maybe manipulate a puzzle piece or manipulate a small component of a much bigger system that gives you a different outcome, that's when this game or this career or this pathway, whatever you want to call it, gets extremely fun. So do it.
Thank you.
Yeah. No, thank you. Thank you for having me.
Thanks for hanging out with us today.
Don't forget to rate, review, and subscribe wherever you listen to your podcasts.
Check out our show notes for bookmarks to your favorite sections and links to resources that we mentioned in today's episode.
You can also find past episodes and see what's on deck for upcoming ones at pct.edu/podcast.
And of course, we are open to your thoughts, ideas, and suggestions, so send those over at podcast@pct.edu.
It's been real.
Catch you next time.